Hello everyone, and welcome to another video. Today we are going to be going over weather maps in our science class. A couple of things have changed about our Canvas course for the month of November and December, and I would like you to take a look in Canvas now. I have created a video for you to watch about the things that have changed. It's important for you to watch this video before diving into these notes because I have changed how remote students and remote learners, including A Day and B Day on their remote days, take notes in the class. This is on a virtual interactive notebook. That's how we'll be taking our notes now when we're on our remote days. For students that would like a printed copy, they can get one after they complete their notes. If you have circumstances that make it hard for you to access this virtual interactive notebook, please let me know as soon as possible, and we can discuss that together. So now I'm going to get into weather maps and what weather maps are. We have spent the last few weeks learning about the different weather tools and weather patterns that can happen. These tools are used to measure these weather patterns for the amount of precipitation, the temperature, the air pressure, the humidity. And then meteorologists can use that information to build radars and other graphs to show us what weather patterns we should expect. So today we're going to talk about those. So the first thing I would like you to do in your scientific notebook, again, we're using the online one if you are remote today, is you're going to fill in the following chart. The first piece I want you to fill in is the what you already know. So what do you already know about weather maps? What have you already seen that meteorologists have shown you either on TV, maybe on your phone, maybe in a news article? The next thing I want you to fill out is what do you want to know? What is something you hope to learn today during this lesson? And then the last one I want you to fill in at the end of today. So there's several different symbols and graphics that meteorologists use to communicate the weather forecast to us. We know from earlier this semester that meteorologists use a range of different weather tools to help them predict the weather, but now we'll learn how to read these reports. So this picture here is of a weather radar, and I want you to think about what this may mean. What does the red mean on the map? What does the yellow, green, the blue mean? So there's two different types of reports that I want us to talk about. And these are reports that are made to meteorologists so they can build their forecast for us. So a surface report is the first one, and it describes a set of weather measurements made on Earth's surface. Weather variables are measured by a weather station, and a weather station is a collection of instruments that report temperature, air pressure, humidity, precipitations, wind speed, and wind direction. Believe it or not, cloud amounts and visibility are often measured by human observers. So at these weather stations, it is very common and normal for a meteorologist to step outside the building and take a look around and then decipher or decide how much clouds forecast he thinks there will be, whether it's overcast or low visibility, maybe it's scattered clouds, maybe there's no clouds, and the visibility, how far he thinks he could see. And this is very important for drivers and people who cycle outside and anyone really who's doing an outdoors activity. A second report is an upper air report. An upper air report describes wind, temperature, humidity collections above Earth's surface. These atmospheric conditions are measured by a radiosonde, which is a package of weather instruments carried high above the ground by a weather balloon. Radiosonde reports are made twice a day, all at the same time in hundreds of locations around the world. And it's pretty neat that we can get all of this data all together, and that all these reports can be compiled or gathered together in one place to then show us what will happen with the weather. So satellite images, we talked about earlier this semester that technology plays a big role in the reports that are made in the forecast we see. Images taken from satellites that orbit about 35,000 kilometers above Earth or in the exosphere, they provide information about weather conditions on Earth. These images detect both visible and infrared light in their images. So I want you to think back to earlier this semester when we learned about visible and infrared light. Turn in your scientific notebook and use this chart to reflect back on what they are. In the visible light spot, I want you to write what you know about visible light. In the infrared light spot, I want you to write about what you know about infrared light. And in the middle, I want you to write about what they have in common. So visible light is the light that we can see. This is the sun's rays. This is any energy that we can actually see that provides light to us. Infrared light is the light that we cannot see because it's too far in the red side of the color spectrum. Infrared light is often referred to as heat light, and we can see it with an infrared camera that'll show us the heat patterns of something. Think back to earlier in the semester, I showed a picture of a cow under an infrared light and how the infrared camera picked up the infrared light coming off of the cow. We saw that in the middle of the cow there was a concentration of red, or there was a lot of red in the middle, and this red spot showed us that there was a lot of warmth there. For what they have in common, these both are used to predict weather conditions, and they are both used when images are taken, especially from these satellites that orbit above Earth. So let's talk about how meteorologists actually communicate this information with us. So meteorologists use these satellite images to identify fronts and air masses. And I want you to take a moment, think about where this weather front may be. So the weather front will be this line of rain. And so this line of rain is being formed at this weather front because there's two air masses colliding with one another. Remember that a weather front is when two air masses collide, and they can often create precipitation in the middle. So meteorologists use a Doppler radar, and this showcases what they have inferred from satellite images, and it communicates a forecast with us. A radar kind of looks like this, where we can see that this light green is showing where it's probably raining, but maybe not as much. As in the dark green area, it's raining more, and then the yellow is raining the most. If we take a look at the graphic on this side, we can see that there is I don't want to call it a symbol bank, but there is a legend for us to look at that shows us that when it's a white map, when the map, nothing's there, there's no rain or less than 1 inch. When there is yellow, it's between 4 and 6 inches. When it's dark purple, that's above 20 inches, and that would be a lot of rain. So let's take a look at the image of a Doppler radar. Is this what you expected it to look like? Because I didn't. A Doppler radar, a physical Doppler radar, kind of looks like a golf ball to me, which is kind of interesting, kind of cool. So now in your virtual scientific notebook, I want you to write down what a Doppler radar is. So a Doppler radar is a specialized type of radar that can detect precipitation as well as the movement of small particles, which can be used to approximate the wind speed. So how can this happen? How can it approximate wind speed? Well, we know that wind speed causes the movement of precipitation, and it rushes from areas of high pressure to areas of low. Thus, a Doppler radar can be used to estimate that wind speed as the precipitation in that front moves. We see Doppler radar images in our everyday lives, especially in news reports that meteorologists broadcast, and even on our smartphones. You can see a lot of weather apps on your smartphone will show you a weather report and will show you a Doppler radar. So, turning to your virtual interactive notebook, I want you to think about for a moment, why do you think it's important for us to measure wind speed? So last week in our area, we had a lot of wind rush through here. Wind was very high. And there was a couple of warnings that came along with that wind. Really high wind speeds can affect drivers. It can blow down trees. It could damage sensitive crops. There's a lot of variables that go in and a lot of reasons why somebody might want to know the wind speed. So I want you to write in your notebook one reason you think, and then I'll read over these and share them with you. But for me personally, I think it's important for us to know wind speed so that we know how to plan our day, and we know when we need to be cautious when wind speed may cause a severe weather condition. So let's talk about the station model. The station model displays data from many different weather instruments for one location. This means every location could have a different station model. Most likely, Raleigh, North Carolina, and New York City, New York have very different station models, especially during the winter months when it tends to snow a lot in New York City. A station model looks like this. So what the station model is showing us is that there's no sky cover, because in the middle here, there's nothing here. If this was completely filled in, that would mean that this would be overcast. But since there's nothing in this circle, it means there's no sky cover. This line shows us which way the wind is pointing. And so this is showing us that the wind must be pointing northwest. And then these little tick marks show us how much wind there is. And we're going to talk about what these mean in the next few slides. Above the weather condition, so here's a weather condition. This is showing us that it's probably raining, or that it's going to rain quite a bit. This is the temperature. This is the dew point. So this is when dew forms. This is the pressure trend. So this is our air pressure. And this is our sea level pressure. And we're going to practice more with these today. So let's talk about station model symbols. Station models use a number of different symbols and display all kinds of observations from surface reports and upper air reports in one easy-to-read model. Here's what each symbol means for that sky cover. So this is that middle piece here. And what we see is that a empty symbol means 0% cloud cover, and the observation is clear skies. A fourth of the symbol covered means 25% cloud cover or scattered clouds. If 75% of the circle is covered, that means 75% cloud cover, or 3/4. An observation is broken clouds. And if the full circle is covered, that means 100% cloud cover, and the cloud observation is overcast. So these are the precipitation symbols that I want you to know that can be used in a station model. Rain is usually shown by dots. So light rain would be 2 dots, moderate would be 3, heavy would be 4. And snow is usually shown by little stars. They kind of look like snowflakes. Light snow is 2, moderate snow is 3, heavy snow is 4. So let's talk about how we read the wind. I've already answered this question earlier in this video, but I want you to write down in your scientific notebook, which way is the wind in this station model blowing? So, as I said previously, the wind in this station model is blowing northwest. This is north, this is east, south, and then west. So northwest is where our station model is blowing. How do we read the wind? So when we use a station model to read wind speed, what we want to do first is look for the direction in which it's going. The line of the wind speed symbol will point in the direction which the wind is blowing in. Each tick mark that is added to that line will account for 10 knots of wind speed. So wind speed is usually measured in knots. So instead of measuring it in miles per hour or kilometers per hour, which sometimes it is, and usually that is shown to us, a lot of stations will first measure it in knots of wind speed. So if there are 2 tick marks in the main wind line, then there is 20 knots of wind. And that's what we see here in this station model. So how do we predict the weather from weather maps? Weather maps use more symbols than just the station model. And while that can make that harder for us to read, it also gives us more information that we need to know. Most of the time when we want to know the weather, we will start by looking at weather maps. So this is a cold front. It points in the direction it's moving. So this one's moving down. It's moving away from the upper hand, left corner, and towards the bottom, right corner. And a cold front is shown to us by these little triangles, and it's usually blue. A warm front, on the other hand, this one's moving up towards the top of the image, is shown in red, and it's typically shown with half circles on a line. Stationary front is kind of a blend of both. This is where there's a cold and warm front on both sides. This one's staying still. And then an occluded front is kind of this dark purple color, but it also will include both the triangles and the circles. So let's talk about how we can read different kinds of weather maps. So this is one kind of weather map that's showing us how the winds are flowing, is showing us the air pressure systems, and we can kind of infer where weather fronts will happen, or we can guess where weather fronts will happen off of this graphic. So isobars, which are shown here, those black bars, are lines that connect all places on a map where pressure has the same value. So let's find an isobar on this map. There is one labeled for us here that we can see. And this isobar is kind of curving on the outside of Florida, and there's one in the middle. There's a low pressure system in the middle. We're going to talk about that a little more. So isobars show the location of high pressure and low pressure systems. Isobars also give us information about the wind speed. So it can show us which way these winds are going. You see where it's red, winds in the low pressure system are flowing counterclockwise around the lows. Winds in the high pressure system flow clockwise around the highs. And winds in the purple sections flow roughly parallel to where our isobars are. When isobars are close together, we know that the winds are very strong. Winds are weaker when isobars are farther apart. So if we look up where that high or that H is, the isobars to the right of that are kind of close together. This may suggest that the wind is stronger here than, let's say, the wind that's going over the ocean down here near Florida. There's another one to know, and these two can get a little confusing because they're almost the same word. But isotherms, which are not shown in this picture, are lines that connect places with the same temperature. So instead of showing us air pressure systems, isotherms show us where temperature is the same. Isotherms show areas where it's warm and areas where it's cold. Lines with symbols on them show weather fronts. So let's look back at this image and let's see any of the symbols that show where a weather front is. Now I'm going to leave this one up to you to decide, and I want you to write down in your scientific notebook where you think this weather front is. So let's go over a couple of practice questions. And these questions are in your virtual scientific notebook for you to answer. Number 1 is, what does it mean if isobars are close together? Number 2 is to compare and contrast what an isobar is with what an isotherm is. And number 3 is, what would it tell us on a weather map, or what would tell us on a weather map that winds are weak? Now I want you to return to your chart at the beginning of your notes. I want you to write down something that you have learned so far. And I also want you to write down an essential question for the day. So I want you to come up with an essential question that will lead you into your notes for the day. There is a spot for you to do this, and I will be checking these. So think about it for a little while and think about what would be a good question to ask that would kind of wrap up everything we talked about today. I hope you all have a great day. Thank you for being here. And remember that if you need any help setting up your virtual scientific notebook, you can reach out to me. There is a link in the newsletter for you to make a meeting with me. I can't wait to see you all again during our next note session.